Okay. Stream should be live now, hopefully. Yeah, so people seem to like the previous Advent of Code live stream. So today I've decided to wait until after work with solving it, instead of doing it sort of during my morning coffee. So as you can see, I haven't looked at this yet. I've tried to stay away from everyone posting about it during the day on IRC. Let's just get into our day 8 here. Okay. Day 8. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you're interrupted by the kid sitting next to you. Their handheld game console won't turn on. They ask you if you can take a look. You narrow the problem down to a strange infinite loop in the boot code. Okay, so my puzzle input is apparently the boot code. Let's just grab that real quick. Okay. This seems eerily familiar. Looks like some kind of super basic assembly kind of stuff. Okay. Yeah, you should be able to fix it, but first you need to be able to run the code in isolation. The boot code is represented as a text file with one instruction per line of text. Each instruction consists of an operation, ACK, jump, or no op, and an argument, a signed number like +4 or -20. ACK increases or decreases a single global value called the accumulator by the value given in the argument. For example, ACK +7 would increase the accumulator by 7. The accumulator starts at 0. After an ACK instruction, the instruction immediately below it is executed next. So that just goes downwards. Jump jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset from the jump instruction. For example, jump 2 would skip the next instruction. Jump +1 would continue to the instruction immediately below it, and jump -20 would cause the instruction 20 lines above to be executed next. NOP stands for no operation. It does nothing. The instruction immediately below it is executed next. Okay, consider the following program. NOP, so this does nothing. Accumulate by 1. Jump +4, so 1, 2, 3, 4. Accumulate by 1 again, so that's 2. Jump -4. 1, 2, 3, 4. Accumulate by 3, so now it's 5. Jump -3, 1, 2, 3. And we're back here. And that infinitely loops. Yeah. First, a NOP +0 does nothing. Accumulators increase from 0, blah, blah, blah. It says the accumulator 5 and jump -3 cause the program to continue back the first ACK +1. This is an infinite loop. With this sequence of jumps, the program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. Immediately, because we don't have conditionals in this. Immediately before the program would run an instruction a second time, the value in the accumulator is 5. Run your copy of the boot code immediately before any instruction is executed a second time. What value is in the accumulator? Okay, so let's just make. So yeah, I downloaded the input here. I'm thinking we do. So I also I made the text bigger this time, so that hopefully you'll be able to see it even if you have slightly less, or if you're internet isn't fast enough to load at full resolution. You should still be able to see it. So yeah, import stereo tills. We're gonna do. Let's just grab instructions, and that is read file. So I think we used the iterator last time. This time we're gonna split on new lines. I think there might even be. Okay, that doesn't seem to work. I think there might be one specifically for splitting on new lines. You know what? Let's do this instead. 2sec lines input.txt. There we go. So I don't think we're gonna bother parsing this. Like, we could write an npeg parser and parse this into some kind of structure, but I don't think we'll bother with that. And let's just, yeah, I just pinged him because he said he wanted to watch it earlier. Instructions, and let's make this easier to format afterwards. Let's do this. So let's keep the accumulator, and let's also keep the current instruction, like what your instruction pointer would be, and also the visited instructions. I'm gonna say that this is just a set of, how long is the input? It's 600 lines. We need at least a 16-bit integer. So sets, as I think I explained last time, can't hold a full integer. So we'll just use an unsigned 16 integer instead. And then while instructions, while current instruction, not in visited instructions, so it's 0, the set is empty, so it's not going to be in there. And now we are going to run the instruction. I will, you know what, we should probably pre-parse this. Not that we need to for this, because we're never going to execute the same one twice. So it's just extra work. But I think we might benefit from it afterwards. Let's not do it yet, though. So let's do opcode, or yeah, instruction is instructions, current instruction. We're going to split that on a space. So that means we will have sort of the operation split on the space, and then we will have a positive or negative number. And then we're going to do case instruction 0. So this is a string of nop. We're just going to do a discard, and then of yeah, I know. Well, I don't know because I haven't looked at the task. Oh, tomorrow. You're still pessimistic about having to run this or build this into a proper computer thing. Free Yeah. So I'm thinking, let's create a block here called run instruction. And afterwards, we're going to say visited instructions. Include the current instruction, and we're going to increase the current instruction. No, because that's what I don't want to do. Wait, we can do this. Increase the current instruction. That's going to be inside of this block. Don't think we actually, yeah, we do. So that's just gonna discard. This is gonna be our accumulate thing. And for that we need to parse these. Let's see, does this utils module parse int, does that support? Yeah, it supports positive and negatives. So we're just gonna do accumulator plus equals parse int of the instruction. So 1 will be the thing after the space, which is our number. And of jump, we are gonna say that the current instruction plus equals parse int instruction 1. So that will be 1, it goes to the next one, -1, it goes to the one before. That should work. But here we also need to break out of the run instruction block, because we don't want to add this on afterwards. Current instruction. What? Oh. That also needs to be an unsigned integer. And this needs to be 1. Ooh, but we can't do that actually. Let's just make this a signed integer. Like, we'll never run into the negative case. But yeah, so this should never run into the negative. This will still hold plenty of elements for what we needed to. But if we had cast this to or if we had converted this to an unsigned integer, we wouldn't be able to jump back up. So will this stop right before we add our instruction, then we go to the next one, and as long as it's not in the visited ones, then it runs this. So this will stop right before, like we want it to. So this should be what we need. There we go. We have a number. Let's check if it's the correct number. Yep. Okay, part 2. Right. After some careful analysis, you believe that exactly one instruction is corrupted. Some run the program, either a jump is supposed to be a nop, or a nop is supposed to be a jump. No ACK instructions were harmed in the corruption of this boot code. Okay, the program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. Okay. By changing exactly one jump or nop, you can repair the boot code and make it terminate correctly. For example, consider the same program from above. If you change the first instruction from nop +0 to jump +0, it would create a single instruction infinite loop, never leaving that instruction. True? If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from jump -4 to nop -4, the program terminates. The instructions are visited in this order: 1, 2, 3. That's jumps plus 4. 4. This is now a nop, and this accumulator goes off. After the last instruction, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator contains value 8 with this input. Fix the program so that it terminates normally by changing exactly one jump to a nop or a nop to a jump. What is the value of the accumulator after the program terminates? Right. Is there a smart way of doing this? I mean, there is this. So we can make sure that we never change a nop +0 or -0 to a jump. Let me have a look at the input here. Yeah, okay, but that's like a special case, which isn't really telling us much. Okay. I mean, we could just loop through and try all of them. Like flip all of them and check. I guess that works. I mean, it's not pretty. Right. For instruction set no. So for each of the instructions or set of instructions, we want to make just a copy of the set of instructions. Oh, this is so ugly though. And actually do this is equal to instructions. If modified instructions I dot starts with ACK, then continue the loop because we never want to change those. Actually just make this a case statement again. Oh, this is ugly. You know what? Let's do this, and at least map this splitting thing. Don't do the start split thing. Do of and of nop, then modified instructions. I0 should be equal to jump instead, and if it's a jump, try to make it a nop, and then copy this stuff into here, remove that, indent all of these lines correctly. We don't need this anymore because we're doing that up here instead. this, of course, needs to go in there. If the current, right. If the current instruction is equal to instructions dot length, which means we are one past the highest number, then we can echo out the accumulator and break out of this while loop. Actually, we can just quit at this point. There we go. These reset for every iteration. This, of course, needs to read the modified instructions instead of the normal ones. I mean, this should work. So we go through the entire thing, one instruction at a time. We change one instruction. If it's accumulating, if it's an accumulator, we just continue because we shouldn't change those. If it's a NOP, we change it to a jump. If it's a jump, we change it to a NOP. Then we just run our same loop again. Now checking if we've come one step too far, then we echo that out. Otherwise, we just do exactly the same thing that we did. I guess I could also parse these just to save a bit of execution time. Because now we are actually going to be running the program over and over and over and over and over again. Yeah, let's just keep that. Map it and map it again. This is now gonna return. You know what? We can do one better. We can do op is equal to it's 0 and the value of the operation is this. So now we create a tuple there instead, which means we can tidy up our code a little bit to not use these indices anymore. Up. It's just a little prettification. There. Oh crap, I changed. Oops. Part 1 to part 2. I forgot to copy this. As I've said before, I like to keep my part 1 and part 2 as separate files. There. This was part 1. So let's open part 2. Run this in release mode because this is probably going to be a bit slower. I mean, for us now, the time of compilation is okay. That was pretty fast. If it's correct, time of execution is time of yeah, that's the right answer. Time of execution here I thought would be way longer. So yeah, apparently it wasn't. Someone commented on Twitch, even brute force shouldn't be slow, to be honest. Yeah, it just feels wrong. I mean, it just, I don't know. It's a brute force thing. It just doesn't sit right. But yeah, that was part 1 and 2 of today's. I just can do nested loops. Inset. Wait. Well, the alternative for brute force. I mean, I guess you could execute backwards. So you know that. So you know the programs should exit by running the last thing and then going to the next one. So you can start at the bottom of the file. You start at the bottom of this file, find all jump instructions and NOP instructions that can get you there, like NOP instructions if they were a jump, and then sort of, I don't know, run backwards until you have exhausted all the possible paths and are at the start. Something like that. A string to int converter. Oh no, what? An actual converter? So you got implicit conversion? That is that is ugly. Yeah, ooh. That, no. You should feel bad. No, it shouldn't be a NOP that jumps to .len. I don't think. The way I read this was, if you go here, the way I read it is that it should attempting to execute an instruction immediately after. Ah, okay. Yeah. So either it runs the last one or it jumps to the last one. But yeah, basically generating every execution path backwards from the end condition to the beginning. I mean, would that be hard? I'm kind of tempted to try it, but I have other stuff I need to do today. I wonder, just out of curiosity, which one was it? Which thing was corrupted? 313, which, since this starts at 1, that means 314. So this one, turning this into a NOP, and it should now execute all the way through. So changing that into a NOP, then part 1 should just crash, right? Yeah. Because it ran all the way to the end now and failed. Because part 1 didn't have this exit condition right here. It was only looking for the loop. On the leaderboard. Wait, what? I've been putting this off, or I've been like on purpose not doing this all day, so that I could stream it. I'm not even trying to be on the leaderboard. The leaderboard is from there. The leaderboard is from the time when the task is released, right? It's not when you open it. Yeah. Yeah, I mean, what this is, it comes out in 13 hours. What is that here? That is midnight here. Exactly midnight, actually. No, wait. 6. I was wrong. 6:12. So it comes out at like 6 a.m. Which kind of sucks. I mean, I'm not up at 6 a.m. And if I got up at 6 a.m., I would be in no state to program. It usually takes me like a cup of coffee or two to even get going in the morning. But okay, so what is this ASCII art this time? So this is obviously like an ocean. And I'm guessing we're coming from like the North Pole and going there and going over here to this island thing and then over here. But didn't we go by plane? Yeah, it looks like some kind of path. Like it looks like an old Pokemon game or another RPG kind of map. Like, yeah, we're here and we need to go there. There's a road that goes there across the water. Day 7 solution for part 1. This was my day 7 solution for part 1. Oh, day 6. This is my day 6. Which is pretty simple. What was this one? No. Cousin integrations. Yes or no. Ah, right. This was the yes or no question thingamajig. Yeah. I just created a set of like the set of answers looped through all the passengers included. So question is a letter in this string. So included all of the questions for all of the passengers in the group and then added all of the answers for the group to the total. So part 1, groups, sequence of string, and for group in groups, result plus equals group filter. Filter, wait, what? Oh, right, yeah, so you, yeah. Yeah, so you, instead of, wait, you filter on S lower. Ah, so you, right, so you split on this, but you don't do this split. And then you filter out only the characters instead of so you don't get the new lines. And then you turn that into a character set, and then you measure the length or cardinality of that. Yeah. Pretty much the same. Just shorter. Yours solution. So this was part 2. Yeah, so this was basically just like doing the inverse. Because we were supposed to do the other thing. Yeah, but here you would have had to do something else, right? Because you needed to get this is the one that everyone answered the same to. So this one you would have to do differently, right? I mean, this is just looking at other people's solutions right now. Let's see for grouping groups. Yeah, so pretty much exactly the same thing that I'm doing here and the inverse there. But I like your solution of turning them into character sets. That was a nice one. but here you do split lines, right? Split lines, that's what it was called. I was looking for that today. Like I tend to do this instead. Oh yeah, bit sets are way faster. I mean, how, like, what? Hashing a single character? Why? But yeah, anyways, as I said, I've got other stuff I need to do today. If you would like to see one of these tomorrow as well, just let me know. It's kind of fun to do them on stream. Bit of extra pressure. Yeah, that's it for today. Yeah. Shadow. Wait. Yeah, Shadow. I've seen you around. Okay. Let's see.